Watching this video, you may have had some trouble figuring out the volume for some three-dimensional figures. I'm going to start off with I'm going to try to teach you a way that looks at all of these shapes that we're covering in our class the same. We'll start off with maybe this triangular prism to help explain it. So the first thing to look at for a prism, in this case, is to try to figure out what is the base that we're talking about. In this case here, I'm talking about a two-dimensional object. What's the base? Well, the base here is a triangle here. How do I know it's the base of a prism? Well, prisms have some parallel sides. In this case here, we have a triangle being parallel to another triangle over here. That's what we refer to the base. So we have, in order to calculate the volume, we start off with finding the area of this triangle, and then we multiply it by one more dimension. We're taking that triangle and we're stretching it one more dimension, and that's going to be able to find it. So we find the volume. So if we take the area of the triangle, which is 2 dimensions, multiply it by one more dimension, making it 3 dimensions, we will find the volume of this prism. Now, we do the same thing up here. Let's take this cuboid. In our class, we call this a rectangular prism. But basically, we can take, now this one's a little bit more challenging of finding what the base is. We could say the base is this rectangle here, and because it's parallel to another rectangle over here. Or we could take this whole bottom one down here, make that the base because it's parallel to the top one. It doesn't really matter as long as we follow the same idea. We're basically going to take the area of the rectangle and multiply it. Where that rectangle gets stretched one more dimension. In this case here, it would be the height of this. And we will get, when we have 3 dimensions, then we have the volume. Again, area of the base times one more dimension. All right. We can do the same thing with a rectangular prism, okay, and a hexagonal prism. In this particular case, we have a 6-sided hexagon down here. The base is basically that hexagon. It is parallel to another hexagon back here. That's how I know it's the base. So I need to find the area of the base times one more dimension. In this case, it's maybe the length or the width, however we want to look at it here. And that would give us the volume. The area is 2 dimensions times one more dimension gives us the volume. So we actually have to know the area formula. So I need to find the area of the triangle, which is 1/2 base times height, times the one more dimension. I need to find the area of the rectangle, which is just base times height, times one more dimension, which in this case is the height. I need to find the area of the hexagon. In this case, a hexagon can be divided with put a line right here. We can get 2 trapezoids. So we can find the area of one trapezoid, which is base 1 plus base 2 times the height divided by 2. And we can do that for both trapezoids. Add them together and then take that area of that whole hexagon and multiply by one more dimension, which is that length, and that will give us the volume. Same actual philosophy of finding a volume of a prism goes for a cylinder as well. We basically look at where's the parallel sides. Well, in this case, we have a circle and another circle. They're parallel to each other. So the base is a circle. So I'm going to need to find the area of a circle and multiply it by one more dimension, which is, in this case, the length of the cylinder. Or if it was standing up, it would be the height of the cylinder. So the area of a circle is pi r squared times one more dimension gives us the volume of a cylinder. Okay, now that's basically for cylinders and prisms. We've just followed the same strategy for all of these. The cube would be the same thing here. However, it's a little bit different from the pyramid and a cone, but these cones and pyramids are based on the same ideas. So in fact, the pyramids are based on the same idea as prisms, and the cone is based on the same idea as a cylinder, except for the fact, and you guys saw this before in another video, that a cone, if it's the same circle and the same height, takes up 1/3 of the space of a cylinder. So it's the exact same idea. We take the base of the circle, multiply it by one more dimension, which would be the height of the cone. But this time, instead of just being done, which would be the volume of a cylinder, we actually have to divide it by 3 because a cone takes up 1/3 of the space of a cylinder. All right, same thing for a pyramid. A pyramid takes up 1/3 of the space also of a cube, all right, or a prism. So in this particular case, if we had a cube that we had from the area of the base times one more dimension that would give us the volume of the cube. Well, the same thing with a pyramid. We find the area of the base times one more dimension, which is the height of the pyramid, and then divided by 3. It's takes up a third of the space of the cube. Triangular base prism, very similar to a triangular prism. We have our area of our triangle times the one more dimension gives us the volume of a prism. Well, a pyramid works the same way, except you'd find the area of the triangle, base times height divided by 2, multiply that times one more dimensions, the height of the pyramid, and because it's a pyramid and not a prism, we need to divide by 3.